Okay, so we're going to use some theorems about parallelograms. So you see I've got diagrams there on your paper. We're going to talk some about what the symbols mean, and then we're going to get into talking about what's actually true about this parallelogram. You should already know that a parallelogram has four sides. Okay, that is number one. It does have to have four sides. What's true about the opposite sides? They're parallel. Okay, you have two sets of parallel lines. The left and the right side are parallel. The top and the bottom are parallel. That's true about any parallelogram. We just talked about with our centers of triangles what these little tick marks mean. What do the arrows mean? What do the arrows on the side mean? That's the parallel symbol. Okay, the arrows are the parallel symbol. The tick marks are the congruent symbol. So, other than the fact that a parallelogram has to have four sides and it has two sets of parallel lines, here's something that's also true about parallelograms. Not only are the opposite sides parallel, they are also congruent. So that means side AB and side DC have the same side length. So we've already got one tick mark and two tick marks, so I'm going to use three tick marks to denote that AB and CD or DC are congruent to each other. So that also means that AD, I'm going to use 4, and BC are congruent. Okay, so somewhere on your paper, I also want you to write opposite sides are congruent. And I would write AB is congruent to DC, and AD is congruent to BC. That congruent symbol is an equal sign with a little squiggle over the top of it. That means congruent. Okay, you need to be familiar with that symbol. Okay, let's look at the other markings here on our diagram. Okay. Does anybody know what we call the line from A to C and the line from B to D? Anybody know what the name of that is? It's okay. I'm not expecting you to. I was just wondering if anybody did. Those are called diagonals. Okay, that makes sense. They're diagonal lines. Okay, those are diagonals. A property of parallelograms is that diagonals bisect one another. Okay, so when you draw the diagonal from A to C and from B to D, they cut each other in half when they intersect. Okay, so from A to this point in the middle, E, and from E to C, those have the same length. Okay, that's why they're marked with two tick marks there. And from B to E and from E to D, those are congruent. They have been bisected. Okay, so here's another property. Diagonals bisect one another. Okay, diagonals bisect each other. Now, those diagonals are not the same length. Okay, the diagonals are not the same length. One of them is longer than the other one. I think it's pretty evident on the diagram there that one of them is longer than the other. Which one's longer? Okay, from B to D, it's longer. Okay, that's a longer diagonal than from A to C. So just keep that in the back of your mind as well. Okay, the last thing we need to talk about are the angles. Okay, are the angles of this parallelogram. Okay, there are 4 angles. They add up to, anybody know when we have 4 angles? 360 degrees. Okay, that's important to know. So we'll write that down here. Angle A, well, let's just say this. All angles add up to 360 degrees. Okay, when we add them all together, we get a total of 360 degrees. That's true about any quadrilateral. Okay, that is true about any 4-sided figure. All your angles add up to 360 degrees. If you can't remember that, think about a square. Okay, think about a square. All the angles in a square are 90 degrees. They're right angles, right? So you got 4 of them. 4 times 90, 360 degrees. Okay, so any 4-sided figure has 360 degrees. A square can help you remember what that total is. All right, so back to the specific property here with parallelograms. Opposite angles, okay, it's all about opposites. Okay, it's all about opposites. Opposite angles are congruent. So that means the angle at A is congruent to the angle at C. The angle at A is congruent to the angle at C. They're opposite from one another. The angle at B is congruent to the angle at D. Okay, the angle at A is congruent to the angle at C. The angle at B is congruent to the angle at D. Opposite angles are congruent. So that's number 4. Opposite angles are congruent. Nope. A and C. Angle A is congruent to angle C. Angle B is congruent to angle D. All right, so one more time. Parallelograms are all about opposite. Parallelograms are all about opposite. Opposite sides are parallel. Opposite sides are congruent. Opposite angles are congruent. And the diagonals will bisect one another. There is one more property I just thought of that I want to add to this. Adjacent angles. Okay, adjacent angles, what does it mean to be adjacent to something? Right beside each other, okay? Beside each other. Adjacent means beside each other. Adjacent angles are supplementary. What does supplementary mean? 180 degrees. They add up to 180 degrees. Okay, so that means angle A plus angle D equals 180 degrees. That also means angle A and angle B. Plus equals 180 degrees. Okay, and I could keep going all the way around this parallelogram right here. I could do angle B plus angle C. That's going to give me 180 degrees. Let's see here. Angle C plus angle D is 180 degrees. Okay, I think I hit all the pairs there. A and B, A and D. Yeah. Okay, adjacent angles. So if they are right next to each other or they share a side, okay, they're considered adjacent angles and they are supplementary. So you add them up and they equal 180. If they're opposite, they're across from each other, then they're equal to one another. Okay, last thing, what kind of figure is at the bottom of your paper there? A rectangle. Well, guess what? A rectangle is a special case of a parallelogram. Doesn't it have all these properties that we've talked about already? Opposite sides are, first of all, it has two sets of parallel lines. The left and the right are parallel, the top and the bottom are parallel. The opposite sides are congruent, they're equal to each other. The diagonals bisect each other, they cut each other in half. All the angles add up to 360. The opposite angles are congruent because they're all 90. And adjacent angles are supplementary, once again, because they're all 90. Okay, but they have one more property that makes it that's a little bit more specific. So not only do the diagonals bisect each other, the diagonals are congruent. Okay, so we'll write it this way. If the diagonals of a parallelogram are congruent. They weren't on the regular parallelogram. They weren't congruent. Okay, they bisected each other, but they weren't congruent. Then it is a rectangle. Okay, AC and BD have the same length. That was not true on the parallelogram at the top of your paper there. Okay, but it is true when we make it a rectangle. Those diagonals have the same length. Okay, so a rectangle is just a specific case of a parallelogram, just as a square is a special case of a rectangle. Did you know that technically a square is a rectangle? It's just more specific. All the sides are, it has all the properties of a rectangle, plus it adds the fact that all the sides are congruent. Okay, so a square just gets a little bit more specific. So all squares are rectangles, but not all rectangles are squares. Just like all rectangles are parallelograms, not all parallelograms are rectangles. Okay, so what I'm going to get you to do with this, excuse me, is I've got a worksheet here that has a bunch of parallelograms on it, and it's going to ask you to apply these properties. Okay, some of it has to do with the sides, some of it has to do with the angles. You've got to decide, are they adjacent? Are they opposite? What's going on? Okay.